Refraction. Refraction of light. Refraction of light is when light goes from one medium to another medium. For example, when light goes from air to water, it bends. That bending is called the refraction of light. And that bending depends on how different the mediums are. So Snell's law helps us calculate how much light bends. So for example, when light goes from air into water, Snell's law says n1 sine of theta 1 equals n2 sine of theta 2, where n1 and n2 are called index of refraction of the medias, and theta 1 and theta 2 correspond to the angles as it goes from one medium to another. So in the incident medium, it is called theta 1, and in the refracted medium, it is called theta 2. So again, it is going to be, theta 1 and theta 2 are measured from the normal to the surface. Not from the surface itself, but from the normal to the surface. So this angle is going to be the angle of incidence, and this angle is going to be the angle of refraction. So the refraction actually depends on the incident angle along with the index of refraction of the different media. So if I was to look at reflected and refracted rays together, ray 1 will be called incident ray, ray 2 will be called reflected ray, ray 3 will be called refracted ray, ray 4 is the internally reflected ray, and ray 5 is called refracted ray as it comes out of the medium. So this is a very good example to tell you what the difference between the reflected and the refracted rays are. So now let's do an example. Ray traveling through a window pane. A beam of light strikes one phase of a window pane with an angle of incidence of 30 degrees. The angle of refraction of glass is 1.52. Beam travels through the glass and emerges from the parallel phase on the opposite side. Find the angle of refraction for the rays inside the glass, and show that the rays in air on either side of the glass are parallel to each other. So in this particular example, what we are given is a window pane and a incident ray that's incident on it, and it says that the angle of incidence is 30 degrees. So now remember that the angle of incidence is drawn to the normal to the surface. So if this is my normal to the surface, this angle is 30 degrees, right? So I will call it theta I, angle of incidence, okay? Then it says that, what do we have to find? We have to find the angle of refraction for the ray inside the glass. So as it is going from air into glass, it is going to go from a lighter to a heavier medium. So it is going to bend towards the normal. So this angle is the angle that we are trying to find. That is theta 2, or the transmission angle, as we call it. So we have to find theta 2, which is a transmission angle, and we can use Snell's law in order to do that. What does Snell's law say? n1 sine of theta 1 equals n2 sine of theta 2. So in this case, my n1 is n1 of air, and my sine of theta 1 is my incident angle. That's 30 degrees. My n2 is glass, so it'll be n of glass times sine of theta 2, and theta 2 is what I am looking for. Okay? So n of air is always taken as 1 as our reference. Sine of 30 degrees equals n of glass, it tells me, is, for this particular glass, 1.52, and sine of theta 2. So now all we have to do is a little bit of algebra, and calculating theta 2 comes out to be about 19.2 degrees. So my incident angle, theta 2, my refracted angle inside plane 1 is about 19.2 degrees. That's part A. Now let's talk about part B. In part B, it says that the rays that emerge out of this is actually equals to that they are going to be parallel on either side of the glass. Okay, so that means I have to calculate as this continues forward, what happens to this ray as it comes out. So now again, if I was to draw another normal, so I'm going to change the color of the marker. This is my second boundary. It is going to be another refraction as it comes out. It is going from glass back into air. So that means that it is going to bend again away from the normal, right? So we have to prove that this line is parallel to this one coming in. So if I was to draw a ray going that way, that's what it's going to look like. Or if I was to draw a ray going that way, sorry, my glass plane is kind of small now. I might have to make it bigger. So if I was to make it bigger going forward, that would be it. We have to prove that this ray going in is parallel to this ray. Now how do I do that? So the way I will do that is if I can prove N1 equals N2, that will be one way. So that means N1 of air at N1 at boundary 1, in this case I'm going to call it boundary 1, equals N2 at boundary 2. If that is true, that's one way of proving that these two rays will be parallel. Okay, well that is actually true because N1 is in air, which is equals to N2, which is also air, which hopefully are going to be equal because they're both equals to 1. The other thing I can do is if I can, what really makes sense is if I can prove theta 1 equals theta 3. What is theta 3? Now theta 3 is called the emergent angle. Emergent ray and emergent angle. So this is going to be my theta 3. So if I can prove that theta 1, which is this one, I called it theta I before, but I'm going to call it theta 1 now because this is going to be my incident angle to boundary 1 and my emergent angle from boundary 2. If I can prove theta 1 equals theta 3, that will be my proof number 1 that these two rays are parallel. So the one ray coming in is parallel to the one ray going out. Okay? Now how do I do that? So at boundary 2, this boundary, this is going to be my boundary number 2. This is my boundary number 1, right? At boundary 2, what do I know? If I call this theta 2, what is this angle going to be? If this is normal to the surface and this is normal to the surface, that means this angle, by a little bit of geometry, will also be theta 2. Okay? So at boundary 2, N2 sine of theta 2 will equal N3 sine of theta 3. Agreed? Okay? This is still N2. This is going to be N2 for glass now. And this is going to be N3 for air now, right? So I know N2 is 1.52. Sine of 19.2 that I got from equation 1 equals N3, which is now air, which is 1, sine of theta 3. Then you do a math and you calculate what theta 3 is going to be, and it comes out to be 30 degrees. That means if this is 30 degrees and this is 30 degrees, that means these two rays are parallel. So we proved part 1 and part 2.